Hello and welcome. If you're serious about learning board-level repair, everything starts with the right workspace and the right tools. Throughout this course, we'll use the same professional equipment that technicians rely on every day. Some of these tools may seem simple, but each one has a specific purpose, and understanding how to use them correctly will make every repair safer, easier, and more accurate. So before we touch a logic board, let's take a look at the essential tools you'll be working with throughout this course. Repair Workbench. Let's start with the Repair Workbench. It may not seem like a tool, but it's one of the most important parts of your workspace. A clean and organized bench gives you enough room to work comfortably and helps keep your tools and components within easy reach. The better your workspace is organized, the easier it becomes to stay focused and avoid mistakes during a repair. ESD mat. One of the first things you'll notice on a professional repair bench is the ESD mat. Its job is to protect sensitive electronic components from static electricity. Even a tiny electrostatic discharge, too small to see or feel, can permanently damage a logic board. That's why using proper ESD protection isn't optional in professional repair. It's part of the standard workflow. PCB holder. Now let's place our logic board into the PCB holder. This simple tool keeps the board securely in place while you're soldering, measuring, or inspecting components. When the board stays still, your work becomes much more precise and the risk of accidental damage is greatly reduced. You'll probably use this tool in almost every repair. DC power supply. Now let's move on to one of the most important tools on the repair bench, the DC power supply. This device allows us to control both voltage and current, making it possible to power the logic board without its original battery. One of its biggest advantages is that it tells us how the board is behaving by showing its current consumption, whether the board has a short circuit, starts to boot, or shows no activity at all. These current readings provide valuable clues before we begin troubleshooting. Later in this course, we'll learn how to interpret those readings step by step. Digital multimeter. If there's one diagnostic tool that every repair technician depends on, it's the digital multimeter. A multimeter allows us to measure voltage, resistance, continuity, and diode values. Before replacing any component, we first need to understand what's actually happening on the board. That's exactly what the multimeter helps us do. In the upcoming chapters, we'll cover every measurement, mode, and learn how to use it during real repair situations. Soldering iron. Next up is the soldering iron. This is one of the tools you'll use more than almost anything else during board repair. It's used for installing new components and removing damaged ones. But using the correct temperature is just as important as using the tool itself. Too much heat can damage the board or lift delicate copper pads from the PCB. Later in the course, we'll cover proper soldering techniques and temperature settings in detail. Hot air rework station. For larger components and integrated circuits, we use a hot air rework station. Instead of heating a single point, it delivers a controlled stream of hot air over a larger area. This makes it the ideal tool for removing and installing surface-mounted components. Temperature and airflow both need to be adjusted carefully. Too much airflow can easily move nearby components and create new problems during the repair. Microscope. Modern smartphone components are incredibly small. Many of them are impossible to inspect accurately with the naked eye. That's why every professional board repair technician works under a microscope. It allows us to examine solder joints, IC pins, damaged traces, and other tiny details with confidence and precision. Precision tweezers. Precision tweezers may look like a simple tool, but you'll use them constantly. They're used to position components, hold parts in place, and safely remove components while using hot air. Having a good pair of tweezers makes delicate repair work much easier and much more accurate. Flux. Now let's talk about flux. Flux plays a major role in producing clean and reliable solder joints. It removes oxidation, improves solder flow, and helps heat transfer more evenly across the joint. Using flux also reduces the chance of damaging the board during soldering. It's one of those materials you'll find yourself using almost every day. Solder wire. To create strong electrical connections, we use solder wire. Choosing the right solder and applying it correctly has a direct impact on the quality and reliability of every repair. Good soldering isn't just about making a connection, it's about making a connection that will last. Jumper wire. Sometimes a copper trace becomes damaged or completely broken. Instead of replacing the entire logic board, we can often restore that connection using jumper wire. These ultra-fine wires allow us to rebuild damaged circuits and bring the board back to life. You'll learn this technique in detail later in the course. Now that you're familiar with the essential tools used in professional board-level repair, you're ready for the next step. Don't worry if some of these tools still feel unfamiliar. As we move through the course, you'll see them in action and learn exactly when, why, and how to use each one. In the next chapter, we'll open up a smartphone and take a closer look at the logic board itself, exploring the structure that makes every repair possible.